All right, so now that this is recorded, so last class we left off in talking about how to simplify roots, radicals, and then how to change from roots to rational exponents and vice versa. So they're asking us on number 15 to use radical notation to write an expression, simplify if possible. So right now, what they're asking us is just, we have it in exponent form. Do you see that we have this is an exponent. We need to change the exponent to a root or a radical. So how do we do that? Well, remember we talked about this last class. We know that if we have x to the n over m, this is the same as m x to the n. Okay. Devin, do you have your hand up? Devin, you had your hand up. Do you have any questions? Okay, because you had your hand up. Okay. Alrighty, so then what are we going to do? Well, we have something inside of parentheses, which is going to be on our inside of our root. This is the cube root of 2 to the x plus 5 raised to the square. Okay. And you can't simplify this. There's no way that you could simplify this. Okay. The only potential thing, because there's 2 in here and then this is a cube root. If this was a 4, then you could simplify, but you don't have that. So that your answer, it's just this. There's no way you can simplify this problem because there's a plus. There's a chain here that you can't get rid of. Now, let's talk about any questions, by the way, on 15. We're just rewriting it. We didn't do anything. There's that's it. You can't simplify that any further. Questions on 15? Okay. So number 16, before we even jump to these, I don't even want to talk about these yet. Why? Well, because we haven't learned about rules of exponents. So I'm going to show you. Rules of exponents. What happens when we have a to the negative 1 power? This is 1 over a. So the first thing we need to do is change this negative rational to a positive, right? With positive exponents. So this is the way you change a negative exponent to a positive. It jumps the border. Is that clear? It goes down. So that's what we need to do first. We need to change this negative exponent to a positive. How? Jumping the border. I'll show you. So you start with 16, and then you have this negative 3 over 2. The first thing is you bring 1 over the whole thing, 16, positive 3 over 2. You brought it down. It becomes a positive when it jumps the border, meaning it goes down. When you change from up and down, your sign of your positive will change. So if I have 1 over negative a to the negative 1, this is a to the 1. Is that clear? If you have a negative on the bottom, you can bring it up and it will make it positive. So these two are interchangeable. So here, if you start with a negative, it's going to jump down and it's going to become a positive. But if you start with a negative downstairs, then it's going to go up and change to a positive. Is that clear? Just want to make sure everybody's understanding just the rules of exponents. Now that we know the rules, then we go back over here because we're not done. We still need to simplify because we learned how to do that yesterday. But now it's in the denominator. This is 1 over the square root of 16 to the third. But this is interchangeable. This is 1 over the square root of 16 raised to the third power. We learned that yesterday. I need room, so I'm going to go ahead and erase this. So we know the square root of 16 is 4, but raised to the third, 1 over 64. And that is our final answer, 1 over 64. Questions on 16. We're going to do the same thing for 17. So we started with 3 over 2. Remember, if we have, look at this, this is your rule that you're going to be using this whole time. You start with something that's a fractional power. You're going to change it to a root. Then you can also do, okay, well, this is the same as the m root of x, all raised to the n. Same thing. That's what we just did right now. We had a fractional x 16 to the 3/2. We changed it to the square root because the 2x to the third, or 16 to the third, equals, well, just the square root of 16 all raised to the third power. So we have the square root of 16 is 4, but 4 is raised to the third. So that's 1 over 64. Questions on 16? Yay or nay? How do we feel about that? Questions? So far, so good? Wendy, you have a question? Because you like, we're good?
No, that's fine. I'm trying to understand it, but yeah.
So we'll do another example, okay? So the first step, maybe that should be the thing that I need. Step 1, change to positive exponent. How do I do that? Well, the first rule, it jumps the border. It's going to go down. It's going to become 1 over 27 to the 4 over 3. Your negative became a positive because it went down. That's your first step. Now that you did that, you're going to be working with just the denominator because there's nothing to do with the 1. So the bottom 1 over, I have to change it to a root. What is this? The cubed root of 27 to the 4th power. The 4 is on the inside, the 3 is on the outside. Then I don't know how to figure this out. So what I'm going to do is I'm going to change how it looks like again. This is the same as 1 over the cube root of 27, all raised to the 4th power. I know, or you know, what is the cubed root of 27? 1 over 3, but 3 is raised to the 4th power. The cube root of 27 is 3. Now we finalize with 1 over 3 to the 4th. What is that? Well, that's 1 over 3 times 3 times 3 times 3. 1 over 81. And that is our final answer. Yay or nay? How do we feel? Is this better? Everybody knows what we're doing here? Because you're going to have to do that on your quiz and on your test. Alrighty. I would like you to try 18 on your own. And then I'm going to call on someone. Just make sure that you put done when you're done. Don't put your answer on the chat. Just say you're done. Take your time. Just make sure you put I'm done or done on the chat so then I can know. So far, 2 people. This is not time. This is not a quiz. If you're done with 18, try number 19. So you're done with 18, move on to 19. If you're not done with 18, you still have 1 more minute. All right, so I'm gonna go ahead and talk about 18. I'm gonna start by calling on. Jose, can you help me? How do I start 81? Sorry, 18. What's my step 1, Jose? Jose, are you in the Zoom room? All righty, so your mic is not working. Thank you. Viviana, how did you start off this problem?
So first you change to a positive exponent.
Okay, so then how does that look like?
That looks like 1/81 positive 5/4.
Correct. And then what would be my next step, Luis?
Gonna be the
Look up here.
root of
Yep.
81.
So it's the 4th root of 81
root.
raised to the
5th.
correct. Thank you. Well, what happened after this, Wendy?
I do the 1 over the square root of 81 to the 5th power, and I forgot the 4. Yeah.
Like
Oh,
this?
Yes, in the parentheses.
Good. And then
Yeah.
Kevin, thank you, Wendy. Kevin, what would be the next step after this? What is the 4th root of 81?
Okay. After that, you need to. I don't know how to explain it.
So what is the 4th root of 81? What number is here? What number, if I multiply it by itself 4 times, it's going to give me 81. Do you know, Kevin, or no?
No, I am confused right now.
So thank you for your honesty. So here, the 4th root of 81 is 3. How did I get that? Because 3 to the 4th is 81. 3
okay.
times 3 times 3 times 3 is 81. So 3 is the 4th root of 81, but 3 is raised to the 5th. Now this is 1 over what?
243.
Thank you, 243. Thank you. So how many of you got 1 over 243? Good job. Good. Good. So it's 1 over 243. Excellent. Now we're going to move on to number 19. Again, the same steps, except this is not a number. It's just a variable. So it's even easier. So again, 1 over x to the 4 over 9. This is the same as 1 over the 9th root of x to the 4th. And that's it. You can't do anything else. There's nothing that you can simplify You can say, oh, well, that's the same as 1 over the 9th root of x raised to the 4th, but that doesn't matter. You don't have to do the step. There's nothing that you can simplify there. How do I know when I'm done simplifying? If n over m, so if n is less than m, you're done. So we had 4 over 9. 4 is less than 9, so you're done. Look at number 81. 5 was bigger than 4, so you know that you had to simplify. 4 over 3. 4 is bigger than 3, so you know that you're not done. However, if we look at number 15, 2 was less than 3, so you know you were done. Do you see what I mean by you're done or no? You guys are quiet. Tell me on the chat. Is that clear or no? You're not clear. Okay. So what if we have x to the 9 over 4? Who is bigger, the top or the bottom? The top is bigger. If the top is bigger, you need to simplify. How do I know that? Because this is the 4th root of x to the 9. This is the 4th root of x times x times x times x times x times x times x 9 times. Then you can take 1 pair of 4, 2 pairs of 4s. So this simplifies as x squared, the 4th root of 1x. You can still simplify. But if you have x to the 3 over 4, 3 is smaller than 4. So here you don't have nothing to simplify because this is the 4th root of x times x times x. There's nothing that you can take out because they're saying you need 4 of the x's in order for them to be taken out. But you don't have that. So you're done. You don't simplify that. You can't. There's nothing you could do. Is that clear or no? Is that better? Okay. So that's what I mean by if n is smaller than m, means that you don't simplify, but if it's bigger, then you simplify. Okay. So I'm going to erase all this. Again, this is recorded. I need room. So I'm going to do number 20. What did we say about 20? This is a negative exponent on the denominator. So guess where it's going to go now? It's going to go to the top. Exactly. Again, we use a to the -1. It goes down. But if it's already down, you're going to go up. We're going to use that property again. But it starts in the denominator, so it's going to go up. So my first step is to, step 1, change to a positive exponent because that's what they want. That means jump the border and go up. Now you're crossing the border from TJ to San Diego, not from San Diego to TJ. Okay, so for the people that have been to TJ or San Diego or so far, well, I go on the weekends. My husband's family is from TJ, so I go every weekend. But I have Century, so I'm good. I'm VIP. Okay. Anyway, so then you're gonna bring this up. This becomes x to the 8 over 3. And then I'm gonna ask Luis, can this be simplified? Yes or no? And how do you know? Luis, can we simplify this?
Yes.
Why yes? I'm going to give you a hint. Look up here.
It's going to be the same thing than 19.
Right. You can simplify because 8 is bigger than 3. The top is bigger than the denominator. The top is bigger. So that means you bet your puppy that you're going to simplify. So how do I simplify? Well, I have to first change it to the root. What do you mean to a root? This is the cube root of x to the 8. I can simplify this. How can I simplify this? Well, there's two options. You can say this is the cube root of x times x times x times x times x times x. 8 times 1, 2, 3, 4, 5, 6, 7, 8. You're going to take pairs of 3 because this is 3. You need 3 x's to get out of jail. So 1 pair of 3s, 2 pairs of 3s, and that's it. So x squared, the cube root of how many left over? X squared. You simplify. You got 2 pairs, 1 pair, 2 pairs. Oh, look, that corresponds to this x squared. I'm going to answer your question, Wendy, in a second.
Mhm.
I see your hand. And then you're going to say, oh, but you have 2 remaining. That's why you have an x squared remaining. Now I'm going to answer your question, Wendy.
I think you just did. The only thing I didn't understand is why you put the x2 outside the square root, but you just did explain it.
Yeah. So again, there's 2 ways to do this problem. You can say, okay, well, I can take out 2 of them and then, or I'll show you a different way. This is a fraction 8 over 3. You guys can do division, can you not? Do you guys know how to divide 8 over 3? How many times 3 goes into 8? It goes in twice. 3 times 2 is 6, and you have a remainder of 2. This is your quotient, 2, 2 and 2/3. You change it to a mixed number. You can do it that way. And you're going to say, okay, that means x squared, this is the cube root of x squared. These things are your exponents. I'm going to do another example. And I'm going to show you the division way. There's 2 ways of doing it. Because what if I ask you x over 100 divided by 7? You're not going to do 7 and then 100 of these. Is that clear? You're not going to do that. You're not going to make 100 of the little thingies and then, oh, pairs of 7. No, you're not going to do that. So I'm going to do an example like so. Look over here in the corner. X to the 7 over 4. I have to simplify this because 7 is bigger than 4. You have to simplify. So what you're going to do is you're going to change your exponent, this one, and you're going to break it apart. What do you mean break it apart? How many times 4 goes into 7? All I'm working with is exponents, and it goes in once. 4 times 1 is 4, and you have a remainder of 3. So you're going to change this. This exponent will change to x to the 1 and 3 over 4. We changed. Do you guys know how to change mixed improper fractions into mixed numbers? You guys know how to do this? Yes or no? Do you guys know how to do that? Do you know how to do that? There's only one answer. Just put your answer in the chat. You do now? You don't know how? Or you do? If I ask you to change 51 over 5 into a mixed number, do you know how to do that? Okay. So this is basic fractions. This is basic fractions. So before before I even could teach you this, you have to know the basics of fractions. If I ask you to do 51/5, change this. This is an improper fraction. What is an improper fraction? An improper fraction is when you have a higher number at the top than at the bottom. This is an improper fraction. Michael, that is correct. So how do I change this? Well, how many times 5 goes into 51? 10 times, and you're left with 1/5. That's how you change improper to proper. So, do you see the example, Angela? I think you're off.
Well, I got it. I think I just didn't explain it correctly. But
Okay,
if the amount of times 5 goes into 10, and then your remainder is your numerator, the top number, and then the 5 would be your,
exactly.
thank you.
So, yes. So here, so another example, 13/2. How do I change 13/2 into into a mixed number? Mixed number means a whole number and a fraction. How many times 2 goes into 13 evenly? It goes 6 times. 6 times 2 is 12. You're left with 1/2. So 6 and 1/2, it's your mixed number. One more, 17/3. Change that to a mixed number. Don't tell me the answer, just say I'm done. How do I change 17/3 into a mixed number? How many times 3 goes into 17? It doesn't go evenly, but it goes in 5 times. 3 times 5 is 15. You're left with 2/3. Clear or not clear? So you need to know how to do that because that's what we're going to be doing with exponents now. So,
Professor, I have a question.
sure, Ruth.
Okay, so I understood how you divided so you can get the correct answer. But so for number, I believe it's number 20, then our final answer isn't the x/2 to the square root cubed. And then you have x/2. That's not the final answer.
This one is the final answer.
Okay, that's the final answer. And then next to that, you showed how to do
Oh.
the division thing.
Yes, yes, yes.
Because you have both squared out. That's why I was like, which
Oh,
one's
no,
the
no,
final
no,
answer?
no, yeah. The highlighted is my answer.
Okay, thank you.
Yeah. So we're gonna do one more example now that you know mixed numbers. Because you're gonna need that. You're gonna need to know that. Any other questions before I move on? Make sure that you are on mute. I kind of hear background noise. So what I'm gonna do now is do another example like number 20. What if I ask you simplify x 38/6? The first thing you have to do is say, oh, this is an improper fraction. Our fraction has to be modified. This one. This has to change to a mixed number. So this is gonna be, okay, how many times 6 goes into 38? It goes in 6 times. 36. You have a remainder of 2. So this is, the fraction is 6 and 2/6. But guess what? I'm not done. Because 2/6 can be simplified 6 1/3. This is just the exponent of x. Do you see that? This is just the exponent. So I'm going to modify x to the 6 times x to the 1/3. So we have x to the 6th, and then we have this x to the 1/3 remaining. Why? Well, remember using the properties of exponent 6 plus 1/3, it's going to give you 38/6. So this is the whole number, but this one has to be changed to a radical. What does that mean? The cube root of x is on, it's here, and then you just bring down x to the 6th. And that's how you finalize your answer. That one is your answer. Is that clear? Yes? Sorry, yes or no? So all we're doing is focusing on the exponent. You break it down into a mixed number. When you change it to a mixed number, you change it. You have x to the 6th, the big number, and x to the 1/3. The 1/3 has to change to a radical now that it's simplified. How do I know this is simplified? Because 1 is smaller than 3. If you had 4/3, then we're not done. Is that clear? So 1 is smaller than 3. So you know that you're done. And you just bring down the x to the 6. Questions? Go ahead, Wendy. What is your question?
So then, in the case that it's a bigger number on top of a 3, you said that you're not done. Then you have to do what you did on number 20
Correct.
on top of, and
But you
then
don't, yes, but at the end, Wendy, you don't have to because you did that already. So like this one, 6 to the 2/6. If you would have left it like this, on my math lab, they would mark it wrong. They want you to, even though this one's smaller than this one, you always want to simplify your fractions.
okay.
Always. Because if you don't, then you're not done. Like you always have to simplify. So if your answer was 3/6, they're not going to take it. It should be 1/2. Yes? You always want to simplify. Now let's look at use the properties of exponents to simplify. Here, you're going to use the properties of exponents. I'm going to show you x to the m times x to the n means that they add. So I'm going to show you the properties of exponents first before we even get to the problems. X to the m over x to the n means x to the m minus n. M and n are numbers. They're just powers. X to the m raised to the n is the same as x to the m times n. Write them down first and then we'll do them. I want you to write them down. X to the -1 is the same as 1 over x. X to the 0 is 1. X over y raised to the n is the same as x to the n over y to the n. And one more, x times y to the n is x to the n, y to the n. Once you have them down, I'll give you time to write them down. Okay, when you're done, we're gonna get started. So I'm just gonna move it over. I'm gonna make it like this, so then you guys can keep doing it. All right, I'm gonna start on 21. I have two of the same bases. The bases, what is the base here? The base is x. So x to the n, the base is x, the exponent is n. Okay. Definition, the bases are the same. So if the bases are the same, you can add the exponents. This is going to be x to the 7/8 plus 1/8. What's that? X to the 8/8. Oh, what's that? X to the first or x. They add because these bases are the same. X to the m, x to the n. They add each other. So you're adding 7/8 plus 1/8. You add them. You only add the numerators. Do you guys know how to add fractions? I hope you do. I'll kick your butts if you don't. You should know how to add fractions. Add and subtract. And multiply and divide. And if you haven't done so already, I would recommend you to go to Math 81 and there's a notes of adding and subtraction, adding, subtracting, dividing, and multiplying decimals. Okay. I'm going to use number 22 now. What is 22 doing? First, identify at the base. The basis is y. What are they going to do now? They will subtract. Why? Because they're dividing. So this is going to be, and I'm going to write it in black, y to the 3/4 minus 1/4 using this property. Using property number 2. So then I go ahead and say, okay, well, that's y 2 to the 4th. But I can simplify that. That's y and 1/2. They only want positive exponents. Everybody sees what we're doing on 22. So you start with division. They have the same base. The base is y. So the exponents will subtract 3/4 minus 1/4. How do you subtract fractions? The denominator have to be the same. Are they? Yes, it's 4. So what's 3 minus 1? 2. So 2/4. But you don't leave it like that because you can simplify that to 1/2. So my answer is y to the 1/2. Yay or nay? Questions? Go ahead and ask them. Because we're going to do 23 next. Same idea. Look at the base. The base is y. The exponent. The y is the base. So what is the exponent going to do here? Marisol, what are the exponents going to do? Add, subtract, divide? What are they going to do?
Subtract.
Subtract. Thank you. So this is y 1/8 minus 5/8. That's y negative 4/8. But that's y negative 1/2. Am I done?
Yes.
Yes. Let's redirect.
No, we don't need a negative, right? I don't know.
What do
Oh,
you mean? What does it say here?
positive exponents.
Is y to the negative half positive or negative?
No.
It's negative. So guess what? It has to jump the border. It has to become positive. So this will change to 1/y to the 1/2. This one has a ticket to jump the border. He's going to go to TJ for a while. He has to go positive. Is that clear? It has to go down. Lauren, you have a question?
So if it's a negative, we would just add a 1 over the whole equation
Always.
that we got. Okay. Thank you.
Using the same property that I have over here. You're gonna bring it down. Okay, let's look at the next one. I kind of like this one. So here you have the bases are the same. What is the base? The base is 12. They're the same base. So what is the exponent going to do? They're going to subtract. So this is 12, 1/7 minus a negative 13 over 7. Because the bottom already had a negative, but you're still subtracting. Is that clear? Don't miss that negative. So then what happens when you have two negatives next to each other? It becomes addition. So this becomes 12, 1/7 plus 13 over 7. This is 12, 14 over 7, but that's 12 squared, which is 144. You simplify the exponent. You simplify it. 13 plus 1, 14 over 7. Wendy, what's your question?
So we don't touch the base at all.
Never.
Okay.
Don't touch the base, no. Because look at all of the rules of exponents. Did we touch the base? No. So you don't touch the base. That's why we can do all these tricks, because the bases are the same. So they have to stay the same. You're not touching the base. But good question. All right, let's look at 25. They're next to each other. They have the same base. The base is z. So the z will stay as z. What are the exponent going to do? Add, subtract, multiply, or divide, Ruth? Thank you, Lauren. Thank you, Michael. Ruth, what are they going to do?
Oh, sorry, I didn't hear you.
That's fine.
They're going to be subtracting.
So if they're next to each other, they're not. If they're next to each other, they don't.
Oh wait, my bad.
Subtract.
Sorry, they're not dividing. Sorry. Yeah, so these are gonna be adding.
Correct. They're going to be adding. So then we have z, negative 2 over 7 plus 3 over 7. And then we simplify. Z, negative 2 plus 3, that's a 1/7. And that's it. 1/7, right? Good. Now, any questions on 25, by the way? There's time to ask questions if you have them.
I have a question on 24.
24, yes.
The right before the answer, the 12 to the second power. How did you get that?
What's 14 over 7?
Okay.
Marisol, 14 over 7?
Yeah.
Two?
Sorry. Yeah.
That's fine.
okay,
And then 12 squared is 144.
thank you.
Yeah, you have to ask questions if you have them. Don't stay with something and you're going to be like, "Ugh, I have a question, but I don't want to ask." You want to ask these questions. All right, look at 26 and look at this last one. R and X are not the same base. You cannot combine them. You're going to say, oh, I want to add 1/3 and then 1/3. No, because they're not the same base. You have different bases, R and S. They're not the same, so you cannot combine them together. But there's an exponent on the outside. Whenever there's an exponent on the outside, it multiplies to your inside. So this becomes R to the 1/3 squared, S to the 1/3 squared. You multiply your exponents, r 1/3 times 2, s 1/3 times 2. How do we multiply 2 times 1/3? Is this 2 and 1/3? Hell no. What is it? It's 2/3. This is basic multiplication of fractions. R to the 2/3, S to the 2/3, and you're done. You're bringing it inside, Lauren.
So instead of rewriting it, can we just do the 2 times 1, 2 times 1, and that's our answer? Or
Yep.
should we
You
always
can do
write
that.
it out?
Yeah, you can do that.
Okay.
But writing the steps is better because then you don't get confused. So you need to be careful that these are different. So you cannot combine them. This 2 is going to multiply. It's going to multiply to this and to this. Questions on 26? Let me see if there's more. Yeah, there is more. So I'm going to finish this section and then we are going to move on. Questions on 26? Yes or no? This is the time to ask questions if you have them. Okay. Use the properties of exponents to simplify, write with positive exponents only. What's the first thing that I want to do? I see something negative that I don't like it down there. I need to do what? Bring it up. Notice that they all have the same base. I'm going to bring this up here. I could do that because it has a ticket to jump the border. He has a visa. So he's going to go up. So this is going to be x to the 3/5 times x to the 6/7 times x to the 1/3. Questions on just that first step? Step 1 was bring the negative exponent to the top and change it to a positive. Questions on part 1? What's the next step after this? You learned something today. The bases are the same and they're next to each other. The fractions will do what? The exponents will do what? They will start with an add. Thank you, Wendy. So I'm gonna be adding 3/5 plus 6/7 plus 1/3. How do I add this? Using the what? How do you add these type of fractions? You need the what?
The LCD?
The LCD. Excellent. I need to find the LCD of 3, 7, and 5. Let's go find it. The LCD, be careful, Raina. 3 is not divisible by 35. So we need to find what goes in there evenly. So we have 5, 7, and 3. This is going to be what? 5, 10, 15, 20, 25, 30, 35, 40, 45, 50. And then there's more. 7, 7, 14, 21, 3, 6, 9, da, da, da. And the way that you want to do this is We know that the LCD is going to be the multiplication of 5, 7, and 3. What is 5 times 7 times 3? That's going to be our LCD. 35 times 3 is our LCD. 15, 1, 105. 105 is the LCD of all of them, believe it or not. So my LCD is 105. So what is this one missing? This one is missing a 3 times 7, a 3 times 7. So up here, it's gonna be 105 over, use your calculator, 3 times 7 times 3 times 7 times 3, so 6 times 7 is 42. Plus, what is the other one missing? This one is missing a 5 times 3. It's missing a 15. 90 over 105. Plus, this one's missing a 35. So 35 over 105. All am I doing is adding fractions. So here, this one.
For the first one, isn't it 63? 3 times 7 times 3.
Oh, yes. Thank you. 63. Thank you. Because 3 times 7, 63. Yes. So using your calculator, you're going to do 63 plus 90 plus 35. That's 188 over 105. That's the exponent. X to the 188 over 105. But I'm going to ask, can I simplify? You can. How do I know? Because my top is bigger than the denominator. So I have to change this to a mixed number. How many times 105 goes into 188? It goes in once. And using your calculator, 188 minus 105 is 83 over 105. So my answer is X to the first times X to the 83 over 105. So in this case, you want to simplify. There's two ways. You can leave it like this or X to the 188 over 105.
Professor, which one is correct for Math Excel?
I think they would want, it says use a property to simplify. I think they want this one.
Thank you.
Yep. But if they ask you to write it in radical, so if they ask for radical, they would ask for X and then 105, the cube root of X to the 83. If they ask for radical, you change it to this formula. But that's not the case right now. They only want positive exponents only. So it's X 188 over 105. This one was a little bit complicated because it's not a pretty number. Is that clear?
I have another question, sorry.
Yes. Ruth, what's your question?
Oh, my question is, so we have X times, X over 1 times X, 83 over 105. And then the final answer was X 188 over 105.
Yes.
But I
but-
didn't understand how at the end we just put the 188 because since we had the 83, like how did we go back to 188?
Oh, okay, because they didn't, they want you to use positive exponents only. So here, these two are the same. X to the first times x to the 83 over 105. And you ask for what do they want on Math Excel? So I circle this one. Because right now they're asking us to simplify this to something with positive exponents only. So both of them are correct. They just look different.
Okay, I understand. Thank you.
So you're just simplifying. Okay. So here, you're going to use properties of exponents again. There is no negative exponent here. Do you see that? There is no negative exponent. But I want to show you something. This is negative 5x to the 3 over 7 squared. The square is going to go both to the negative 5 and to the 3 over 7. So the property is negative 5 is going to be squared and x to the 3 over 7 is also being squared. What do you mean because it's negative, Lauren? Can you explain your question? Or was
So
that?
would we times the outside because it's a number?
What do you
or
mean the
because it's a
outside?
negative?
Can you explain what you mean by that?
Squared? So how the
This is
whole
the-
equation is squared?
So I want you to go back and look at this property. These are two bases. Negative 5 is a base and the other x was a base. So the exponent on the outside will be distributed to both bases. So we have a
Okay,
base
thank you.
of negative 5. So there's negative 5 is a base and x is a base. Base, base. It's going to distribute to both of the bases because it's on the outside. Here, this becomes, so I'm just focused on the top right now. The bottom is still the same. The bottom is fine because it doesn't have a negative. So I'm not going to take care of that right now. So this is going to be 25 from this, negative 5 times negative 5. And what happens to this? These two will multiply. X to the 3 over 7 times 2 over 1. This is x to the 6 over 7. They multiply using the properties of exponents. The bottom is x to the 4 over 5. I'm almost done. There's a property that I have to do. What property is that? Think about the bases. Which one have common bases? We have x's. So we need to simplify the x's. X, x. Oh, this is a fraction. The exponents will subtract. There's a 25 on the outside, x to the 6 over 7 minus 4 over 5. The exponents will subtract. How do I subtract these? I need LCD. What is the LCD? Well, this one is 35. Yeah. So 6 over 7, you multiply top and bottom by 5. The next one, you multiply top and bottom by 7. 30 minus 28 all over 35. 2 over 35 is the exponent of x. So 25 x to the 2 over 35. Questions on 28?
Professor, I have a question.
Yes,
Sorry.
go ahead.
I guess I got lost when you did the, when you rewrite the 25, the equation, and then on the bottom it's x to the 4/5.
Yes.
That one, using the one of the rules, you just do a negative. I got confused over here where it says when you write the 25, it's
So look over here. We're using the property that their two bases are the same with exponents. So whenever they're dividing, Wendy, this means that the exponents subtract.
okay. Yeah.
So they're subtracting this and this have to subtract. So 6/7 minus 4/5. I don't know how to do that because they don't have the same denominator. So I have to make it.
So
And
this
then
is the last step on this equation after we find the top one, right?
Yes, yes. So you go by steps, like you don't want to jump and do everything at the same time.
Yeah, I got lost somewhere. Thank you.
You're good? Okay. Excellent. All right, let's move on because I think there's more. Oh, there isn't more. Okay. Easy. So let me see what we have next. I want to do one more and then we'll go on break and then we'll do 7-3. So I'm gonna make one up. I make up nasty ones because I like that, because I want to make you work. I want to see how far are you understanding. So I have we're gonna go over this one together. Step 1. You're gonna say, okay, you have bases. You have -2, you have A, and you have B. Those are your bases on the top. I'm just focused on the top right now. Don't look at the bottom. No. First, look at the top. There is an exponent on the outside that has to be multiplied and distributed to everything that's inside your bases. -2 is going to be raised to the third. A squared is going to be raised to the third. B squared is going to be raised to the third. It's going to distribute to every single thing in there. Then I'm working just on the top. Don't think about the bottom. Then what is -2 to the third? That's -8. This is -2 times -2 times -2. That's a -8. Now, what happens with these two? They what? They multiply using the rules of exponents. A to the 6th, B to the 6th. Yes or no? Just the top. Just the top. Now I'm going to look at the bottom. And you're going to say, oh, there's a negative. Oh, I'm going to go to the top. Wait, not yet. Because there's an outside exponent that has to go inside again. Don't move it yet. So I'm going to be looking now at the bottom. I'm going to use the brown. So 5 is going to be squared. A is going to be squared. B to the -1 is going to be squared. You're going to distribute your exponent first. Now you're going to clean it up. 25 A squared B to the -2. They multiply. So then, any questions on the denominator? I don't want to move fast. I want to make sure that we're moving at a good pace. Yes or no? Questions? Okay, you guys are good? Now the numerator is what we had. The numerator is negative 8a6b6 over 25a squared b to the negative 2. Now, this is when we start combining the exponents. Look at the bases. We have a and a. You can only have one a. You're going to have to subtract them using the rules. A to the 6 minus 2. They subtract. They subtract. So negative 8a to the 4th goes up top. These will cancel now because you worked on them already. Same thing with the b. The b is also your other base. So you're going to have b to the 6th minus a minus 2 using properties of exponents. So when you have two minuses, they will add. Negative 8a to the 4th, b to the 8th, all over 25. Questions here? This is the time to ask questions if you have them. All right, if you don't have any other questions, we're going to go on break. I'm going to pause the recording. Let me pause it. Alrighty, so we're back from break. So let's go ahead and talk about simplifying radical expressions. Now we want to simplify radicals. Okay, so the first thing is that how do we simplify the square root of 20? Well, 20 does not have a perfect root. So not two numbers will give me 20. So if I multiply two of the same numbers, they will never give me 20. However, we can break down 20. 20 breaks down as 4 times 5, where one of them has a perfect root. So we're going to split it as 4 times 5. Remember, using the properties of square roots, we're able to break this as a square root of 4 times the square root of 5. Okay, we learned that. We know that the square root of 4 is 2. So this is 2, the square root of 5. Questions on 1? I would like you to try the square root. This is just an additional. The square root of 48. How would we break down the square root of 48? We need to do what? We always want to break it down to something that has a perfect root. What multiple give you something that will be 48? Think about the multiples of 38. What is divisible by 38? Other than 4. 4 is 1, 4 and 12. But there's something more than 4 that is a perfect root. 24 and 2, be careful there, Raina. So 24 times 2, but 24 is not a perfect root. What is a perfect root? 1, 4, 9, 16, 25. These are perfect roots. I want something that has a perfect root and it's divisible by 48. Other than 4. Who can tell me what that is?
It's going to be 8 times 6.
Be careful. 8 and 6 are not perfect roots. This is 48, but this is not a perfect root. 16 and 3. 16 is a perfect root. This is the square root of 16 times the square root of 3. The square root of 16 is 4 rad 3. You always have to find the perfect root. Let's look at number 2. Number 2 is not a number. Number 2 is something. I kind of like this one because we're going to use rational exponents. How do I change this to rational exponents? This is y to the what? What's n over m? What is the root here? Is it a 1? No, it's a 2. So y 9 over 2. Can we simplify this? Yes, we're going to change this to, this is an improper, we're going to change it to a mixed number. 9 over 2 is the same as 4 and 1/2. This is the exponent. So this is going to be y to the 4th times y to the 1/2. We're going to have to change this one to a radical. How do I change it to a radical? Well, y to the 4th, the square root of y. And this is our final answer because they want us to use roots, radicals this time. We're simplifying radicals, not exponents. So they want you to give them the radical form. Questions on 2? No questions on 2? All right, so let's look at number 3. The cube root of 81. Is there a number that if I multiply it by itself 3 times, is that 81? 4 times 4 times 4, no. 5 times 5 times 5, no. There isn't. We don't have one. But we can break down, be careful, Serena. So 3 times 3 times 3 is not 81. We're trying to find the cubed root of 81. 81 does not have a cube root, but we can break down 81 as something that has a perfect cube root. What is a perfect cube root? 1, 8, 27, 125, 64. These are perfect cube roots because 1 cubed is 1, 2 cubed is 8, 3 cubed is 27, 5 cubed is 21, 4 cubed is 64. These are called perfect cube roots. So I need to break down 81 as what? What 2 numbers? Be careful. Not 9 times 2. Be careful, Angela. 9 times 2 is 18, not 81. We need 81 is not divisible by 8, so be careful. We're not going to break it as 9 and 9. We're trying to find a perfect cube root that is divisible by 81. Other than 1, of course. 27 and 3. Thank you, Raina. 27 times 3 gives you 81. And 27 is the perfect cube root. What is the cubed root of 27? It's right here. 3, the cube root of 3. We're simplifying the root. So we have 81. We start with that. We're trying to find a number that if I multiply it by itself 3 times, it gives me 81. There is no such number. But if we break down 81, then as something that contains a perfect cube, like 1, 8, 27, these are perfect cubes. 81, is it divisible by 1? Yes, but that's dummy, so that's useless. Is it divisible by 8? No. Is it divisible by 27? Yes. So it's 27 times 3. That's why you get 27, because 27 is a perfect cube. Let's look at any questions on 3. So I want you to try same thing. The cubed root of 128. How do I break it down? Well, there is no number that if I multiply it by itself 3 times, it's going to give me 128. But I can break down 128 as a perfect cube, the greatest perfect cube that you have. 128 is divisible by 64 and 2. You break it down. So this is the cube root of 64 times the cube root of 2. What is the cube root of 64? 4. 4, the cube root of 2. That's your final answer. Questions here? You always want to get the greatest one. Alrighty. Number 4. Number 4, I'll give you a hint. Change to rational exponents. Marisol, what is my rational exponent? How do I change this to a rational exponent? This is p to the what?
1/8.
Huh?
Oh, no. P to the
Remember the rule that we had?
and 300.
What is it? X to the what? This is something that we all have to know now.
X to the cube.
No. How do we change this to improper? 8 over 3. Your numerator, your denominator. Your numerator, your denominator. Your numerator, your denominator. We've been doing this for the past 2 days now. I do expect that you do your homework, everybody, and that you're working on. So not just because it's not due, that doesn't mean that you're not going to do it. There's homework that you have to do. These things you should be able to know like this. And that's everybody. And if you're not, you're going to have trouble with your quiz on your next midterm. And your grade is going to go to the garbage. You don't want to do that. You want to practice. So this is p to the 8 over 3. Am I done? Do I have to simplify? Yes, because 8 is bigger than 3. So I have to change this to mixed number. This is what? The 3 goes into 8 twice, and you're left with 2 over 3. This is my exponent of p. P squared times p to the 2/3. The 2/3 has to change to radical. P squared, the cube root of p squared. So from here, you change it back to, so you go back and forth to radical and exponents, to radical, to exponents. If you have questions, you should be asking me. If you're not getting it, you have to let me know. So you're going to do the same thing with 5. Same thing. Change it to rational exponent first. X 27 over 4. Who is bigger? The 27 is bigger. You need to change it to a mixed number. Change this. How many times 4 goes into 27? It goes in 6 times and you're left with 3 over 4. So you divide, how many times 4 goes into 27? 6, 4 times 6 is 24. You have a 3. 6 is your big number, your remainder, and your denominator. If you still don't know it, you have to let me know. So this changes as what? X to the 6 times X to the 3/4. 3/4 has to change to radical. This is going to change to the 4th root of X to the 3rd. And the X to the 6, you're just going to bring it down. You're expected to know this for your homework. Wendy?
Yes, I just, could you make it clear? Over here, because I got confused on the previous one, but on this one is the same. The 6 you do on your answer, you have to do the X to the 6 times because you,
They're next to each other. Yeah, so it's like a times. So
so it's just separate, the
They're
X
just-
to the 6.
because this is a whole number, X to the 6, this
Uh-huh.
is a fractional. So that becomes a radical. Because
Uh-huh.
the radical, remember, X to the N over M, I keep doing this, X to the M,
To the end, oh,
always,
Cool.
always. So this is a fractional exponent. So it has to change to a radical.
oh, yeah, I got confused there. Super confused. Thank you.
That's fine. The 6 it's not a fraction. So that one's gonna just stay as X to the 6 because that's good. Now we move on to 6. So 6 is a number. Now we're trying to find perfect 5th roots, G. So we're trying to break down 96. Let's think about perfect 5th roots. 1 to the 5th is 1. 2 to the 5th is 32. 3 to the 5th is 243, I want to say. Right, Enrique? 3 to the 5th is 243. So I want to break down 96 as something that contains one of these numbers. It's not going to be 243, obviously, because 96 cannot go into 243. But what about 32? This is 32 times 3. We break it into something that contains a perfect 5th root. Who are perfect 5th roots? These right here, 1, 32, and 243. So you have the 5th root of 32 times 3. We break it down as the 5th root of 32 times the 5th root of 3. The 5th root of 32 is what? 2. This is the 5th root of 3. There's nothing that you can do. So your answer is 2, the 5th root of 3. Okay. Questions on 6? No questions on 6? I would like you to try one question on your own. The 4th root of, let me see. The 4th root of 243. Now you're going to think about the perfect 4th roots. 1, to the fourth is 1. 2 to the fourth is 16. 3 to the fourth is 81. 4 to the fourth is God knows what, 256. So I know I have to stop right there. Because I want to break down 243 as something that is either divisible by 1, 16, 81. How am I going to break down 243? And I have 2 answers on the chat right now. They're correct. What 2 numbers are divisible by 243 that are either this, or this? It's just a process of elimination. It's divisible by what? It's divisible by 81. 81 and 3. So this becomes the 4th root of 81 times the 4th root of 3. What is the 4th root of 81? Oh, that's 3. And then you have the 4th root of 3. And that's it. And that's it. Questions on the extra one that I just did?
My confusion is on the 3, the final answer, the 3.
On this one?
And on the other one, yeah, the 3. So,
So do you understand how we break this down?
oh, that's why we get the 3, because of,
So we
Yeah.
get the 4th root of 81 and the 4th root of 3. And then we simplify. What is the 4th root of 81? What number, if I multiply it by itself 4 times, give me 81?
okay,
The only number is 3. So 3 is the 4th root of 81. And then the other one can be simplified. So you just bring it down.
okay, thank you.
Yep. So we're going to do the same thing with 50. So be careful here. We're going to start splitting them. Remember when we did that? We split it. Wendy?
Just to make it clear. So on the answer, you put the 3. So the 3 is a whole number, and then the 4 square root of 3 to the 4 power, that is an exponent, right? To the answer.
No, no, no. I don't know what you mean by double. So your
Okay.
answer is this.
I know, but what my question is 3, and then it's the exponent is the 4, the square root. No,
This is the 4th root of 3.
I know. No sé cómo explicarlo.
So I don't think I know what your question is.
I know, yo tampoco la puedo hacer en inglés. Okay, that's fine.
No, no, no. So what I think, so you have your whole number, you simplified this 243. This is the 4th root of 243 of a number, a 4th root, right?
I got, yeah, all the steps and everything. Just my question is over here on the answer. Like you write the 3, it's a whole number. Look, but the square root or to the 4th of 3, you just rewrite.
You bring it down because you can't simplify that.
Okay, but it's not an exponent, right?
No, we're not, this is not exponents. This is
Okay.
radicals.
Okay,
Exponents, we already did.
okay.
Our answer has to have a radical because that's what we're doing. We're simplifying radical expressions. So no exponents right now. We start with exponents because that's going to help us sometimes. Sometimes, like number 2, we change to rational exponents and then we change it to roots because that helped us. But our final answer for this section 7.3 is radicals only.
So the answer is 3 and then the square root of
4th
3.
root of 3.
Okay.
Correct. So we're going to use the properties of roots. Last video, I would want you to go to the video that we did last class. I did like the whole thing on roots. Like I did something like this. So go back to your notes. I don't know if it was 7-1. 7-1. I talked the properties of roots. Look, take your notes, look at your notebook and go back to this because we're going to use them right now. Seven one. At the end of 7-1, we talked about roots. While you find that, I'm going to go over there to 7-3 because we're going to need them. We're going to start to use them again. We're going to split it. Whenever we have a multiplication as a times b, this is the same as the square root of a times the square root of b. That was one of your properties. So that's what I'm going to do. I'm going to split it. The square root of 50 times the square root of x squared times the square root of y. And then I'm going to start simplifying them all. I start by simplifying the square root of 50. Do we have a square root of 50? No, we don't. No two numbers, if I multiply them, will give me 50 as a return. But I can simplify 50 as what? This breaks down as 25 and 2. Oh, 25 is a perfect root. I know. So this is 5, the square root of 2. We break down 50 as something that contains a perfect square, which is 5 root 2. Yes or no? I'm just going to go slow. I want to make sure everybody's with me. I don't want to lose anybody. We're going to cross the river holding our hands. Once I finish the first, I'm going to look at the second one. X squared inside a square root. I can simplify this. This is x squared over 2. If I change it using roots, using rational exponents, they split. X 2 over 2 is just x. That's how you simplify the next one. Questions? Again, this goes back to this. This is like exhaustive. Tattoo this in your arm if you have to. This is something that we've been doing for God knows how long. So that's what we're going to do. That's going to help us. Well, what about the last one? Can we simplify that? We have a 1 here and a 2 here. This would be y to the 1/2. 1 is smaller than 2. So we're done. We can't simplify that. So that's going to stay as the square root of y. We can't do anything to that one. We can't simplify it because 1 is smaller than 2. And then this looks weird. My answer will not look like this. How will my answer look like? And I'm going to ask, who is under the roots? Who have radicals? This and this. They have radicals. So this is going to be 5x, the square root of 2y. The ones that have radicals, they go together because they have been simplified now. 5x goes in the front, and then everything else with the roots will go together. Yes or no? This is the time to ask questions.
Professor,
Yes.
I understood the final answer and everything about how they go together. My question was just that when you split them,
Yeah.
and then we were I don't know if it's like reducing or I don't know what we were doing, but you split them. Simplifying, yeah. You added a 2 and then a 1 to the y.
What do you
So
mean?
you put a 2 on
added.
the out. So you put a 2 on the outside of the square root of y, and then you
Yes.
added the 1.
Yes, I didn't add the 1. So I know what you mean. So whenever you have a square root like this, Ruth, you don't see it. Like it's not there. But there's always a 2 here.
Okay.
And then whatever it is, so if I have a y, you don't see nothing on the y, but it has an exponent of a 1. and you, again, and you use the same property.
Okay, so if it were like an X, then it would still have the 1 and a 2 on the outside or whatever it is.
Exactly.
Okay, thank you.
So right now, you don't usually, you're not gonna put 2 and then 2y. You don't need that. Because it's kind of like obvious. Right? So if I give you like the square root of 25, you're not gonna put 2 the square root of 25. It's like given. It's like it's already there. So on 8, we're gonna do the same thing. We're going to split them. Square root of 300 times the square root of k to the 7 times the square root of q to the 8. If you need to put the 2 on the outside, that's fine, because we're going to do that. So we're going to break down 300 as what? This is divisible by 100 times 3. Why did I pick 100? Because 100 is a perfect square. So the square root of 100 is 10, and you're left with the square root of 3. I break it down into something. Michael, do you see it's a 3, right? Times 3? Okay. So then 10 root 3. Now we look at the second one. We're going to change this to a rational exponent. K to the 7 over 2. Can we simplify that? We can, because 7 is bigger than 2. I have to change that to a mixed number. This is going to become k to the 3rd times k to the 1/2. How did I get that? Well, how many times 7? 2 goes into 7, 3 times. You have a remainder of 1. K to the 3rd, k to the 1/2. So we're done with the 300. We're done with this one. Now we're going to move on to q to the 8th. Q to the 8th, this is q8 over 2, because this is a 2 here. There's an imaginary 2 there, always. So that's going to be q to the 8th. Sorry, q to the 4th. I can't divide now. So I have a few things. I have 10 radical 3 times k cubed times k to the 1/2 times q to the 4th. There is something that I have to fix. I have to fix this one. That has to change to a radical form. This is the square root of k. Bring everything down. And then what is the last step? To put the square roots together. Which ones? This and this will go on one single square root. So I'll have 10 k to the 3rd, q to the 4th, the square root of 3k. So I'm not going to move on to 9. I'm going to stop. I'm going to wait. And I want you to digest this. If you feel confident, you could do number 9. I'm not going to do it yet because I want to make sure everybody's with me on the same boat. Step 1, split it. Split the 300, the k, and the q. When you split it, that means you're going to start simplifying. You simplify 300 as 100 times 3 because 100 is a perfect square root. When I break it down, it's the square root of 100 times the square root of 3, but the square root of 100 is 10. So that's why I got 10 and the square root of 3. Questions on that first part? I'm going to move on to k to the 7th. K to the 7th is in the square root. That's k to the 7 over 2 if I write it as a rational exponent. I have to simplify that exponent. 2 goes into 7 3 times. That's how I got this 3. And I have a remainder of 1/2. That's how I got this. Those are my exponents, k to the 3rd, k to the 1/2. I move on to the q. Q to the 8th in a square root is q to the 8th over 2, which is q to the 4th. I bring it down. And then I notice that there's a q to the 1/2 that has to be changed to a radical, because these radicals have to combine at the last time. Questions here? I want to make sure I address the questions. Wendy?
So when do you know when to change it, like in this case?
What do you mean?
On the K, that you're changing it because it's a fraction or,
It's a rational exponent.
I don't know, to
So-
change it to the square? That's, I got confused there, but I didn't to ask.
Yeah, so I changed the 1/2 to this. How do I know that I have to change it? Because it's a rational exponent. And you can't simplify this any further. So 1 is smaller than 2. That's how I know I'm done. So when I change this k to the 1/2, I go back and I mention, how do I change rational exponent to a square root? That's the square root of k to the 1st power. So that's how I change it to the square root of k. Does that help, Wendy?
I have a question.
Yes, Marisol?
So at the end on the final answer, when you put them together, does the order matter when you?
So yes, the normally the number goes at the beginning. So the 10 goes at the beginning, the 10, and then the square root will always go at the end.
Okay,
So
thank
yes,
you.
the order matters.
Okay.
I'm gonna try and I'm gonna finish 9, and then that's gonna be it for today, okay? I don't want to do like a lot of problems, and then I don't want you to feel overwhelmed. We'll end up with 9, and then we'll start 10 on Monday of next week. Or you guys are good? You want to do one more, or do you guys want to call it a day? You tell me. One more? So if you want to go, that's fine. Put your name and your last name on the chat if you feel confident, but I'm going to do one more because I want you guys to do your homework. So the first thing is I want to break it down. I need to. I'm going to break this down as this is a cube root now. The cube root of 343 times the cube root of x to the 4th times the cube root of y to the 5th. Okay. I am going to start by looking at the perfect cubes. Does 343 have a perfect cubed? Use your calculator if you have to. And it does. The cube root of 343 is a 7. 7 times 7 times 7 is 43. Is 343. So this one you're done. You don't have to break it down because it has already a perfect cube, which is 7. We're going to jump to the next one. I have to change this to a rational exponent. X to the 4/3. This tells me that I can simplify this because 4 is bigger than 3. I have to change this to a mixed number. This is going to be 1 1/3. 3 goes into 4 one time and it has a remainder of 1. So this becomes x to the 1 times x to the 1/3. I do the same thing with y. Y 5/3. I have to change 5/3 to a mixed number. How many times 3 goes into 5? Once, and I have a remainder of 2/3. That will be my exponents of y. Y to the first times y to the 2/3. I know that 2 is smaller than 3 and 1 is smaller than 3. So I have to change these both to radicals because they have rational exponents. This will be the cube root of x. This will be the cube root of y squared. Now I have to put them all together. I have a 7, I have an x, I have a cube root of x, I have a y, and I have the cube root of y squared. This is not my final answer because I still have to put the roots together. Who have roots? These have roots. So I have to put them on one single one. So I have 7xy, the cube root of xy squared. Now this is my final answer. Questions on 9? This is the time to ask questions. I still have 1 minute. And I want to answer them if you have them. This is really repetition. As long as you do the same process and you repeat, you'll be good to go. I'm going to pause the recording